All right. Yes.
More or less stupid question, but because I forgot to use it, and instead I looked up the area. Would that be?
Yeah, but
would it be okay if I only use 2 decimals for this?
Oh, you use like 1.65 or something? 1.64?
That's
sort of. But I mean, we got to be used to using the T-score chart by now, right? I mean, for these standard for 90%, 95, 98, 99, they're all on that T-score chart. Where would I look to find Z-scores on a freaking T-score chart? Well, just at the bottom. Like it? Like it? All right. So this is the kind of stuff you're going to see on that quiz on Wednesday. So let's get into some new stuff. You guys have all this? Yep. You can react if you want to. I don't care. All right. So when we have a test for a percentage, so if I said I thought more than 50% of the students in my last semester class passed the class or something, I'd have to take a sample of them and then see and test it. But what we don't have, we're missing one thing. We know everything. We know how to set up hypotheses, blah, blah, blah. We know with an NPQ problem, you never use T-scores because you basically always know sigma. You create sigma. You always know it. So the whole point, the whole step 2, what do you use? Z or nothing? You check NP and NQ. They have to be bigger than 5. If that's true, then you're good to go. Just like we did a minute ago. Step 3 is the same as always. I'm going to have to tell you some alpha, blah, 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 blah. And then you set up a rejection region, like always. Step 4 is where things change, because I can't use this thing now. I don't have any freaking means and stuff. No, screw it. I have percentages. And if you recall this guy here, which part of this was acting like the standard deviation? This piece. So the Z-star formula for percentages is going to be, I'm going to find a percentage from a sample. I'm going to compare that to the percentage in the claim. And I'm going to divide by the appropriate standard deviation, which will be this. One little thing. Notice that these guys, you got to love any math class where you can say the next sentence. These guys aren't wearing hats because if I know Pete, it's in the claim, so I'm going to use that. So the only place our hat shows up is right there for our data point right there. So obviously, let's do a problem. Let's try this out. All the steps are the same, and then the 5th step is write your conclusion. We have found evidence. We have not found sufficient evidence. Whatever it is, everything is basically the same, except this little thing and this formula. That's the only differences between the hypothesis tests we've done already and the ones for percentages.
Just like before, when I was asking, you said check NP normality if it's greater than 5 we're good to go. In the case that it's not greater than 5, I don't know if we're going to problem like this. You said make N bigger.
No. We don't have that luxury here because we're not the ones taking the sample. So if I gave you a problem where one of these is less than 5, I probably made a mistake. That would be, I don't understand. Do you guys try to understand? If I did that, that would be so evil. Because if you noticed it was less than 5, you wouldn't do the rest of it. You say, I can't do this shit. And if you didn't, you would waste a lot of time. And I'm sitting up here going, that's too evil for me yet. Give me a few more years. Then I'll be all like, yeah, screw all you guys. No, I'm not there yet. So I would give you one where that would work. If it doesn't work, you have to assume either I made a mistake or you made a mistake, and you just keep going. Because I'm not going to do that kind of trick. You understand? The one in the book was if you had control over your sample, you just go take more people. Because you're the one doing it. I like it. All right, so let's try a problem out. Let's say, let's use 0.10. Okay. This is Jeff's attempt at being funny, but I was like, dude, I'm right if I'm like this. I'm right there on the edge. If you do go crazy, go like a non-violent crazy. That'd be great.
Omar has a question like that, just the opposite. That's about the happiness.
Oh yeah, that'd be better. Yeah, but for some reason, stats problems are more often morbid than happy. So first off, what's the claim that's being made?
More than 75% has to be.
So now in mathish, what is it?
H1's greater than 7.
No. I can't make any of these greater. These are statements.
Oh, okay.
What is the statement? Yeah, good. Not you. It's going to be P is greater than 0.75. I like it. Stop there. Is that cool? The claim that's being made is that more than 75%. So I'm claiming the percentage is more than 75%. Cool. So which one is that going to be? Good, the high. Because it doesn't have equal sign. So what's the ho going to be? Let me stop there for a second. You guys all right?
Yeah.
Just accept it and move on. How many tail tests will this be? One tail test, which direction? Yeah, it's going to be up. I like it. So I want more than 75, so it's got to be more than that enough. We'll see what happens. I have no idea how this is going to come out. Let's find out. So secondly, what do I check to see if I can use z-scores? I guess I can see that. Cool. Focus. Focus, little camera. There you go. Can you use Z or nothing? What do I check again? NP. So what's N?
408.
Yeah, N is 408. And what's P?
0.75.
0.75. I love it. Not P hat. P. 0.75. And then Q will be 408 times. What's Q got to be? 0.25. It's 102 and 306, right? So those are both way bigger than 5, so we're good there. So the same exact steps, just 2 of them are different because I got to use NPQ. This is an NPQ problem, so the requirement for normality is different. N greater than 30 doesn't mean shit anymore. It's got to be NP and NQ bigger than 5. And then on the step coming up later, we got to use this different Z-star formula because I got to use the one that's got p hats in it and p's and stuff, right? So the third step is my rejection region. We just said we can use Z-scores because it's normal enough. So for an alpha of 0.10, it's a one-tail test. Alpha is 0.10. Can somebody help me find the... We already said it's a one-tail up there. What's that Z-score going to be? No. One-tail test, 0.10. 1.282. Yeah, cool. All right, let me stop there for a second. Everybody able to find that on their own? So, one-tail test, 0.10. Let me ask this question. What confidence interval would this be related to? It would be this, right? So if there's 10 there, there would be 10 there. It would be related to an 80%. That's why we haven't seen that number much, because we never made a freaking 80% confidence interval. I don't want to be 20% chance I'm wrong. So we very rarely make 80% confidence intervals. Oh my God, it's horrible. So that's why we haven't seen that number before, really. It's kind of a pathetic number, but oh well. Yeah.
I just have like a concept question. Why do you use like 90% confident versus 98% confident? Like you always want to be like the most confident thing. You know, like different problems. Like,
So again,
studies, just like out of curiosity, why people would choose to use 90% confident rather than 98% confident.
Because if we're cool with the 95% confident level, then why would I push it up to 98, which could make my confidence interval way wider?
Okay.
So if I'm 5% sure and then my confidence interval is only like 5 wide, but then 98 makes it 20 wide, I'm going to say this. Yeah. Here, there's a whole other layer that makes physical sense. Again, the whole thing about if I'm in a nuclear reactor, I'm going to make this freaking thing big. So that the minute that it goes into, I'm like, oh shit, I'm going to... But if I'm an insurance company and you're trying to show me evidence that I should lower your rates, I'm going to make this small. So it makes it very hard for you to pass the test. Right? I'm like, it's too bad for you. Your rates stay the same. All right, does that make sense?
Yeah.
So now it's got a whole other reasoning behind it for hypothesis tests. So how do I say this in words? If Z star is greater than 1.282, we can do what? Reject the hoe. Support the high. Now, I do want to say, if that offends anybody, if I ever offend you, just wait a few minutes. I'll probably do it again. All right. Now that I've established what enough evidence is going to be, I go see if I got enough evidence. I check out my Z star from my sample. But now I've got to use that new Z formula that's got the p hats and stuff in it. All right, so now I want to use this formula, Z star equals p hat minus p over the square root of pq over n. Oh, there's so many places to make calculator errors here. Let me pull this up here. I'm going to erase that. Everybody sees those quizzes, right? That's too bad for you. If you're online, it's right there. I'm showing art. You forget? It's too bad. Okay. All right, so let me pull this up here. Step 4. What's p hat? We got to calculate that. What's p hat?
0.7.
Yeah, where do you get that from?
It's the 321 divided by 4.
Yeah, 321 we found out of 408. What'd you say it was, sorry?
0.79.
7,
9.
9.
Oh, I rounded. It was 7.78 something, so I just started.
7868.
787?
Yeah.
Let me stop right there. You guys, now I have a problem I'm going to let you guys work out. I'm going to leave this problem up here on the board so you can follow it. But how you guys doing so far? P-hat, please, dear God. It seems that less and less people now understand percentages and how they get them, but it's just the part divided by the whole. Your p-hat can't be bigger than 1. Don't just do the whole problem and get p-hat of 1.07. I mean, that's crazy. 107% of the people I talk to, that's a problem. Did you include imaginary friends? I don't know. Well, then that explains it. So z star equals p-hat, 0.787. What's p? 0.75, right? It's always the number for my hypotheses. Guys, 0.75 divided by the square root of 0.75 times 0.25. Is that cool? P cubed over n 408. So this, dear God, you can make so many neat mistakes in the calculator doing that. Right? Put the top in parentheses so the calculator knows what the top is. It doesn't have eyeballs, so you got to help it out. Right? The TI 2000 don't have eyeballs in it. That's one step away from the end. I'm curious how this comes out here. Okay. What'd you guys get? Anybody get that?
1.76.
1.7. I got 1.73. 1.73. Let's see who remembers this. Can you take a second and find the p-value for that? You're all like, dude, I don't know. Alpha and this z-score have the same relationship as p-value and my z-score. They're exactly the same relationship. Yeah, I guess.
0.0418.
0.0418. Okay, sounds about right. So it's going to be the area and the tail that this z-score makes. 0.0418. I don't hear anything else. Everybody says that sounds good. How did he find that? It's magic. Yeah, just look at the z-score chart, right? 1.73, you get 0.9582. 1 minus that. Or you do the shortcut if you know the shortcut. You guys okay so far? What's up? If you have a question, ask it now. It's a really good time. So did we make it far enough away? Yeah, we made it right. We made it up in there. Cool. So then, what can we do? Reject the hope. Support the high. Which language will I use? Support the high, because the high was the claim. Whichever one's the claim, that's the language that you use. Because that's the next level that people have trouble with is, well, how do I know when to say reject or support? Which one's the claim? The claim is H1, so I use this language, not that language. So we have found sufficient evidence to support the claim that, where was our claim? More than 75% of stat students go insane. Sad but true. We have a whole wing at this. Yeah.
Can we use the negative language if we don't support, saying that
If we
we have found insufficient evidence to
yes,
support?
if you fell here,
Yes.
then you would say we have not found sufficient evidence to support the claim. Yeah, I like it. So I'm going to leave that up there. You guys can work alone or together. Do the side that says chapter 9, not the side that says chapter 10. You're not ready for that yet?